So let's start trying to implement the new compute mesh. So um, I started to rewrite the unit test for core to index, where I'm putting the because uh, get voxel function is expensive, so uh, we don't want to call it every single time whenever we want to create a mesh to modify, because yeah, we need that to identify if there's a position to it. So there's a bit of an explanation to this for the creation of mesh, but yeah, uh, I don't really think that yeah. So we put it in a one-dimensional array, converting the coordinates x, y, z into an index for an array for faster access. So I think that's the fastest way to access the value of the octree, because we're just creating um, a mesh here. So we'll just dump it anyway. We'll just temporarily setting the value here, basically just calling it once, because here if we don't do this, will this get voxel will call multiple times and will slow down the code. So we did that for optimization, but I really think later on it requires me to really delve into it. So okay, so for this development, um, we are trying to rewrite it. Uh, I made a mistake of rewriting this and try, but yeah, I'm now back at trying to rewrite how the the mesh creation of mesh work. So it's always wise to um, break down the task into manageable pieces. So here we are we are yeah. So I think we have to pull the code that's needed of our in our documentation. I think hold on, I'll try to access that one. Hold on, I'm trying to. All right, so here I pulled um, the the diagram of how am I going to rewrite the creation of the mesh. All right, so here the circles are. I really think we should need to add the text here. Maybe a legend or something like that. Maybe this one might be a cool idea. I don't know. Yeah, we just use anything that. Save changes. Able to edit in this draw, enter your console. Yeah, alright, so save it. Alright, so perhaps name it as a legend. Yeah, we'll try everything. Alright, and then we'll just rewrite it as we go along. So okay, the circles our vertex. Arrows. Oh Jesus, I don't like this one. Alright, I don't like this. So I'll just do create unnecessary. Then top text. I really want it to be on top. There you go, legend. Why is it legend? In the map it says legend. Anyway, I'll just use it. I'm used to it, so I'll just change it if it is there's a more appropriate words for it. Alright, so this is circle. I'm talking about this circle here. So we put a legend for that, so for the explanation. And circle vertex. Arrow direction of creation of mesh of triangle mesh. So basically we are creating it. We create a seamless if it is on top and on the left side. If it is in bottom here, we don't create a mesh toward going down or towards the bottom. So yeah, and then we have to simulate it. I think we have to do some calculations to it. Yeah, okay. So alright, so for this one, I'll get the data from the neighboring Octree to set the value of the mesh. Oh yeah, right, yeah. But we'll just create a new text for now. I think perhaps copying this one would be because I don't have to reset it again. So we will create an algorithm, a pseudocode, if you will. Pseudocode. First, really like to maybe seems like I like this better. All right, we'll do. That will do. Okay. So the first one will be, and then we have to put indices for the implementation. 0. 1. 2. 3. 4. 5. 6. 7. Yeah. And then oh Jesus, I think I'm doing the reverse one. Jesus Christ. 1, 2, 3, 4, 5, 6, 7. Right. And here 1, 2, 0, 1. Oops. I have to be efficient. Okay, I'm not lazy. 3, 4, 5, 6, and 7. All right. So how do we do this? I really think we should do this here, right? Should be here. Let's group this. Can we group? Then this. Then group and put it here. All right, because you always, Jesus. Oh, 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 no, 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 no. Group. Then group. There you go. We always want to start with the 0, 0 coordinate in a 2D, but it should be 3D. Okay, um, it's hard to do it. We'll just apply it for 2D. What's applied to 2D, we'll just extend it to 3D. I know it's just one axis added. It doesn't make it simple, but yeah. Uh, if there's a editor for 3D like this, an app that diagrams that .NET that does this in 3D, oh wow, that would be awesome. But I don't know how would you do that. But that's really an awesome piece of software if there is. So all right, let's start with the pseudocode. For this one, uh, so all right, if it is not the end of the of the index, we don't do anything. All right, so um, how do we do that? Okay, so here we are initializing the grid. So basically, the grid is this grid. Yeah, so that's the grid. All right, and then we are just initializing that, initializing its value, because we are doing some calculations to it about surface nets and setting out the layout grid. Okay, so um, yeah, and then this is the one that we want to modify because we are sending the data here, which we are sending back when we are calling the get surface nets. Maybe we have to rename this, yeah, but yeah, for now that works. So let's always start with the x, not the x that you're thinking about. Okay, I'm literally talking about the x-axis. So okay, we go. So yeah, I have to explain this as well, right? So we go this first step here, right? Uh, always do counterclockwise towards the normal of the triangle mesh. What does that mean? I forgot. All right. So basically, the mesh creation is that for it to be really valid, uh, what we are really doing is that we are creating it in a in a way that, so okay, if this one grid and then this two, this one, we are checking the previous one. So no, that's y-axis. Jesus, this is the x-axis. All right, so we are checking the previous one if it has a position, if it has a vertex. So which is defined here in the initialization of grid. And then the grid will ask it. So if we start from 0, 0, 0, yeah, here 0, 0, 0. Do we have a previous one? No. From X, do we have to create a mesh along the x-axis? Along the x-axis is what I want to say. So here, perhaps we could comment this at one out. And then try and see if it runs. What we are doing here is that we could run it target run -p seamless. Oh Jesus, lots of error. Oh man, I really want to remove all this. How about this? We try to remove all of this because I'm so annoyed from all of these warnings. I don't like warnings. I don't like anyone who's giving me warning, but it's a necessary thing, you know. So okay, let's start with the error first, and then we go one by one with the warnings because I really like a clean code. Yeah, it's just making it way easier to develop if you have a clean code. I don't want a mess. So all right, so implement rs Bevy Voxel. So okay, we go to the Bevy Voxel implement. I think it's implement, right? 303. Ooh, yeah, we don't have that. Yeah, but we do have this. Right, can we go here? Let's see. All right, okay. We do. I know some. You're telling me to just full search and rename. Yeah, it does exist. I just wanted to do it the cold-blooded way. All right, it's just simple. Uh, Hardcore. I like it hardcore. All right, so here mod is it in Bevy Voxel as well, right? We should go there as well. No, not the editor. Yeah, I should go also. And then what it says here is util mod, yeah, util mod, yeah, okay, here, easy, right? Then we could run it, easy. Oh, yeah, because this is expected because we are just rendering on the x-axis. We're just creating triangle meshes on the x-axis. So basically, it's facing the x-axis. That's why you can see if you go along with the right, you cannot see it. Face the x, yeah, you can see it, right? So that's what we are creating, right? And then I think we should, yeah, I'm just doing the no, I didn't do anything yet, but I did add here, but we should get back with the pseudocode. Right, so we are doing x. We are okay. Let's close everything that doesn't make any sense currently. We'll just put what remains. It's here, right? Set the text here. That move doesn't make any sense. It's a new one, right? Okay. Then we'll focus here. All right. So far it's good, but we need to focus on the only change that we need to do is the creation here. So it will go here. So that pseudocode is that it will go read the previous axis, create a mesh, a triangle, because in web GPU or any GPU or any graphics library, GL, yeah, it stands for graphics library. They're just creating a triangle to render the mesh. So here we're just rendering a mesh. It will just create a triangle so that once we feed it to the GPU, it will render a mesh, right? So a mesh is just a group of triangles. So anyway, we should go and to create a triangle, conditions to create a triangle. So for now, x-axis is specific. So do this for each axis. Axis is singular, right? So for you'll just check the previous one, the previous Jesus, complete your sentence. The previous grid. Check the previous grid if it has a vertex. If none, nothing. If there is I think you have to, because it's just a triangle, you have to check the if it is x, you have to create another grid that's checking the other one. But for now, what we'll do, sample x axis. Is it axis? First, if there is, check you could do this same procedure with z. Yeah, for y, yeah, it's for now, yeah, same procedure with z. Yeah, we have to confirm that there is, check the y negative 1, y minus 1 grid if there is, if there's a vertex. Of course, if none, do nothing. Maybe we could remove this because it's just lazy. We could remove this. If there is, connect those as triangle. Is that enough? No, I don't really think that's enough, right? Is that enough? What if there's no value here and you want to connect this here, right? Diagonally. Does that work? Yeah, that that does work, but we will do the L. Won't go there, something like this, because there's no position here to connect. So here, here. So yeah. So if here, connect here, facing the Y, facing the Z. No, it's facing the X. So it should be something like this, right? Oh Jesus, that's hard. I mean, yeah, it should be facing Y-axis. Yeah, this is the Y-axis, but to face to face the Y, to face the X-axis, you have to go to, yeah. This is the if you start with 0, 0, 0, you have to, oh yeah, minus, yeah, what's below it, and then what's below the Z. So yeah, it should be here, trying to connect here. So it's a reverse checking. So, and then you have to identify if it is facing left or facing right. Excuse me. Yeah. So, uh, yeah. So we are getting here what's below the what's currently being analyzed. So yeah, here as a grid. Yeah, you connect this. Yeah, I think the same procedure with the Z, but perhaps we have to break it down into if we just remove the Z. Same procedure with the Z. Right? It's yeah, it's just a one face, two triangles, one face. So creating two triangles face. Uh, um, yeah, this is a condition. Okay. All right. So is it returning? Yeah, it is returning. It is returning. All right. It has to fulfill all of these conditions. So yeah, the first condition would be um, if it has a value below it. So negative one grid. Y minus one grid. If there's a vertex below it, if there's none, just return it. Doesn't You don't have to create face. Alright. The second one is if there's uh, wow there should be vertices for each y minus 1 and z minus 1 for alright, we have to identify if it is the current. What is this? Huh. Current in the left. What does that mean? Oh, sorry. No, sorry. Yeah, only one should be true so that it will create phase, because if it's both true, it means that it is inside the of the mesh. If it is, if both of them are false, that means it's just air. There's nothing there, so we shouldn't create. That's why the condition here. Okay, so the for the oh Jesus, was shocked. Okay, so for the no, I'm used to it. Yeah, I want to zoom in. For the Jesus, just complete the sentence. Yeah, I'm a bit. Yeah, I have to reread this and then put it in documentation. What am I doing here? What does that mean, the current? And what does that mean, the left? What does that mean? It's greater than 0. Oh, if it has value, what's on the left, which is this, uh, that means it should be facing left. What? I don't get it. No, Jesus, what? If it is this, and then there's a value here, it should be facing left. What? What? I didn't get it. It should be negative 1. What does that mean? I'm a bit confused. The current is 0, 0, 0, which is analog. Is it this one? So it has to be facing the no. It should be here, because this one won't be eligible rendering here on the bottom. We don't allow that to happen. We are just allowing what's on the if it is going beyond the bounds of the current Octree to its neighbor. For going uh, below the 0 index, we're not allowing that. So okay, so what uh, so so this one, the 00111 grid 11 grid will be eligible to create a mesh, because if there's a point here, you could create there should be or point here. So for now, let's have a point here. We could create a mesh here, mesh, right? So we go down to x, y for now, just y, because we're just doing the same as z for z, but for now it's just y. Okay, right. So for y, if it is the current one, and it has a value. This one has a value, right? This one has a value. It should be facing left. That's true. But if the x here, yeah, which is +1, x +1 here, if it has a value, it should be facing right, which is going there, right? What does that mean? -1, 0, 0. I don't know what. Is that the same as the other one? +1, +1, and z +1. So I think this is wrong. This is wrong. It should be +1, +1. In other creation, it's +1, +1, +1, right? +1. Yeah, here +1. So okay, we identify that, then +1 here, and then facing right. You have to face right if it has a value here. Alright, so if there's value here, this one is facing this. If this one has value here, it should be facing there. Alright. By the way, the grid is really not this grid. I think it should be this grid. So it has a grid here, something like this. And then the positions are here. Alright. But for simplicity's sake, it should be this one, this one, this, right? It should be if there's a point here, the point would be this. That's the grid. Can we make it a bit clear? Can we do that? Can we do that? Oh yeah, okay, we can. This is the grid, right? No, this is the voxel. This is the grid. This is the voxel. So here voxel, here voxel, here. Oh man, I'm a bit confused about this. So if it has a value here, yeah, this one is the grid. This one is the grid, but the positions will be identified inside the grid, but this is the voxel. So if it has a value here, right? Here. If it has a value here, you can only create a value here to here, right? Uh, right. I found a way to have a freehand drawing. Because I don't like this one that it's always rigid. Jesus. Stop drawing. Alright. So remove this. Remove this. Not this one. Then I'll create a search drawing here. This is the voxel. Oh, yeah. This is the voxel. This is the voxel. How does it look like in light mode? If you turn on the lights, yeah, Jesus. Okay. So yeah, this is the voxel. The voxel. And then what we are doing is to identify if there's a position here. Position here, position here, position here, position here, right? So for this one, if it does, for now, undo it. So all right. So for now, we try to identify if it is if there's a value here. So let's do step by steps. All right. So if it has a value, create an example. Having a value here. If no, I just copy paste. I love copy paste. Yeah, we'll just. Oh man, yeah, okay. Conditions. Yeah, 0, 0, 0 conditions. Is it wrong? Pseudo code. Okay, pseudo code. I really like pseudo code here. All right, so. All right, so what was the last time we were discussing? Oh, okay, about the we have to discuss about the creation of the mesh. So we are on the voxel. So we have to discuss about okay, if you we need an example here. So in condition, we have a uh, at 0, 0. No, we make it 3, but we will explain it 2 for now. But if it's needed that we need to do 4, no, 3 axis, then we'll do it. At 0, 0, 0, there's voxel 1. So air is 0, and if there's a voxel, anything, if it has material or something, or maybe land, perhaps, 1. Okay. At 0, 0, there's 1. Okay. So there's 1 here. And then the process would be this is the voxel. Then can we change the brush? Can we change the brush? The size of the brush? Freehand brush. Where's the brush? Brush, 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 brush. How can I edit this? Freehand, freehand draw.io. Okay, so yeah, we want it not so thick because it's so thick, baby. Uh, we want to reduce that. We want to reduce the thickness. We can't stand the heat. Oh, okay, this one, perhaps. Okay, this one. So we have to undo, undo, undo. What? It's saving. Okay. Okay. We have to. How can we erase this? Jesus. Can I select it? Can I select this? Okay, I can select this and then delete. Oh wow. I'm learning. I think. Yeah. This one is the. Uh, let's say point. This one is V1. This one is V1. V1 and V1. V1. And text. V1. V1. What? Right. Then, uh, so the case is if there's a V1, there's a voxel there. How do we how do we create a mesh there? How do we decide there's a mesh there? All right. Uh, so what we are going to do is that uh, there will be a point here. There will be a position here. This is the vertex. How to do vertex? Maybe the color. I could change the color. Perhaps. How would I do it? Uh, it's just the thickness. Increase while draw the shape. Freehand tool. Pencil icon. Where's, where's the pencil icon? There's none. Jesus. Maybe I have to remove and then do. Uh, is it range insert uh, freehand? Where's the brush? Can't see it. Where's the option? Freehand. If you're using Sketch whiteboard editor theme, where is this? I don't see this. Is it this? Style? No. Sketch. Rounded. Sketch. Oh, no, no, no. Do not change that. Okay. It's not related to this. The diagram. Where can I scratch pad general? I don't see where is the pencil icon. It says here it has options. Damn. Perhaps I could freehand? No? No? More shapes? Freehand. Freehand. No, I don't think it's in here. Interesting. Interesting. How can I? How can I? Diagram. And then I can change the color. Oh, I could. Oh, I could change it if I click on it. Okay. Let's turn on the light. Jesus. Okay. And then change this to um, red? No, it's RGBA, RGBA, RGBA. I have to follow the color for those people who are color challenged. Oh, what? Oh, what did I do? I messed this up. What? What did I do, man? I don't mean it. What did I do, man? I didn't mean to do that. Come on. Anyway, I'll just copy paste this, right? And then undo. Oh yeah, redo. Oh yeah, that. There you go. Right, and then we should go back and respect the color coding. So it is RGBA. No, 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 no. It's black, red, blue, and yellow. So here, yellow. Yeah, hello. Yellow. This one should be yellow. Doesn't have to. Doesn't have to. That's fine. What we want is the representation of the position, the vertex. So turn off light, and most likely they will have a position here. Perhaps a dot would suffice. Yeah, dot would be great. Uh, what is this? Come on, man. I'm destroying the Jesus. Oh man. Delete. No, I really think. I really think that a pretending square would be great. X, X, X. Your X. No. Um, I'll just put it a thick. Yeah. Okay. then stop, and then uh, turn on light. My eyes. And then put a color that is RGBA 255. Okay, enter, apply. There you go, and then turn off the light. To save us headache later on. Okay, so this is the position, the vertex. This is the the voxel value at 000 coordinates. All right, and then what it needs. And then how do we decide if there's a mesh to create an x-axis? All right, we it should be facing x-axis, facing x-axis. So it should be this. Should be sorry, wrong. Then it should be this. Oh. This. Okay, so for this one, it won't render anything. All right, because come on, I'm always what? If I don't stop it. Oh man, Jesus. Sometimes it's really hard to do this freehand thing. I cannot click it if this like this. What? I'm not. What? I'm not doing anything, bro. I just want to remove this. Oh, well, it's okay, fine, fine, uh, fine. No, whoa. Uh, Come on, man. Wait, what? I cannot select this one. Uh, what? I cannot. I cannot what? Why? Why do we have to go this way? But there. What? What? This. What? Who is this? A ghost? A ghost in Draw.io. No, app that diagrams that net. Jesus! What is this? A sketch? What is this? I don't. What? What? Come on. Oh, really? Like, right now? What is this? All right. I should try to play it safe. Right. I'll download this, and then we'll see if this one still persists. How to download? Save as, and then yeah, update this one. Replacing this. Then that's the fresh. Open existing diagram, and then where's the ghost? Okay. vanished. It's a glitch. I found a glitch. Okay, V1. No, cancel. Yeah, I don't like it. I don't like it when you're trying to save it without my permission. How can I do this? How can I do this without you asking me every time? Uh, this. If I change this, I just want to live a peaceful life, bro. Anyway, I have to perhaps leave and then have a new one. I always do incognito so that I don't have to clean it. No, I don't believe that Google will not process my data if I'm in incognito. It's just that I don't want to always clear cache. All right, that's it. I know. I know they are getting my data. All right. I know they even know my IP. They even know the last time I logged in the email that I logged in Gmail. It's already addressed here in my IP address. They do have that. So, uh, what? So I know that. Uh, so freehand in arrange, no, insert, and then freehand. Then let's make it thick. This one. Uh, then stop drawing, and then turn on the light. Then okay, get this one, and then change the color. Then turn off the light again, because all right, no ghosts, no props. All right, I like it. Uh, so for this one, there won't be we won't be creating a mesh in x-axis. That would be the job of here. If it is in here, we could have a an octree here below. It will create this something like this here. Uh, yeah, we could discuss that. So fundamentally, it is something like this. If you insist, but this is the edge case. But okay, fine. We'll just address it. So this is the edge case. Okay. Uh, Turn on the light and then change this color to RGBA. Since RGBA, yeah, we'll just use a combination. All right, combination. All right, and then turn off the light. So okay, and then remove this. Put it, arrange it, and then snap back, send to back, and then so that I could get this and then put this. Perhaps we don't have to, or we could move it here. So processing what's in 000 would be the um, yeah, it will have it will process this by we'll have no, can we copy paste this one? How about copy paste this one? Copy paste and then copy paste. Oh Jesus, I have to move that away. Oh, the layout destroyed. No, I should move it. Panic. Do not panic. I'm not panicking. You are panicking. I'm not panicking. What? The zero? Uh, Perhaps I have to move this one. I could always do that. You cannot do that on paper. So I love app.diagrams.net because it gives me flexibility to move things. You cannot do that on paper. So yeah, I love this. Uh, so these four are vertices. So that's roughly their position. But since we're just processing this, we won't have we won't be creating vertex here. So in this example, 0, 0, 0, uh, 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 yeah, we should do example. But the general process would be the same. So example 1 for the condition of can you do tab and then tab just 2? I will just no condition. I just do one. One. Alright. So just to save space, I don't want to have a long. I have to be consistent. Oh Jesus! I have to be the very best. No one ever was. So okay, we just use tab. Okay, we respect it, all right, because it's using tab here above, so we'll just respect it. Okay, I don't want to be disrespected, so I have to respect. And then right here, we have that example. No. Since we solution we do not we so we do the first one. Do this each axis x-axis first. We don't have to do this. Yeah, well, we should do this. Okay, so axis first. So check the previous grid if it has a vertex. So we are checking. No, not really a previous check. We have to check. There should be a vertices for each y minus 1 and z minus 1. So in this particular situation, it is y and x. Okay, so there should be, he said, for now in our case, because we only do this for 2D for now, is that no, we just have to be consistent. We don't have y, so y -1 here. There should be vertex. Yeah, it has, but the next case would be it is the starting index, which is 0, if it is if current current grid is equal to that x, because Jesus, you could understand it as a grid, is equal to 0, which is a starting point. Do not create mesh, else what? Well, I just got. It was deleted. Jesus. Come on now. Yeah. All right. I'll take it. It's not working just like in a notepad. Okay. Here, there should be vertices for each. Yeah. Okay. If there is, no, the first rule should be if grid dot x is equal to 0, return, nothing. Just return. Okay. Then if not, if there's 0, if it is not 0, then there should be vertex. So here the solution here, step 2 is true, therefore no mesh, no face, no triangles, face gray in x-axis. It won't be the same because it's 0, 0, 0 here as well. So wow, that's a future optimization. Oh wow. Okay. Wow. Thank you. I didn't figure that one out. If I'm just thinking, if I'm thinking out loud, I can see that. Okay. Okay. So this one won't work. So we create. How about this? No, right? That's the case 1. Then I'll just do copy paste instead of yeah. So for this one, I'll hell yeah, just copy and paste it and then move it here. That's another case. I will have this case. So that one case, this one case, imaginary. I think let's go and then copy this, and then group this. Set it as a group. this one delete, then move it here. Oh wow, yeah, I need to copy this too. No! I would have, again, a problem. Check. No. No. Oh, Jesus. Sometimes it's really hard to. Alright, I'll just delete. No. I could move it. I could move it. I could move it. I could move it. No, I tried, man. I tried. I'll just delete it to make it faster. Same as here. Put it here. Put it here. Then we do another example, right? Isn't that cool? I just thought about it for the first time. I am that great. I know. Thank you. You're welcome. Put it here. Again, I'm not lazy. I'm just turn on light, then turn it to black, and turn off the light. Okay, so we do what we did here. Yeah, I know it's taking a bit of time, but bear with me. My work is on the line. Brush, start brush, then the voxel. I will get it eventually, okay? What? Come on. There you go. Sweet. Yeah, there, and then stop. Then, okay, change this. Then change this. Change this. Change this. 255. Apply. Then same with the other one. Just make it thick for the voxel. I cannot see it. I cannot see the grid. Yeah, there you go. I can see that. Here. Stop. Then change this. Turn on the light. I'm sorry, guys. It really hurts. I know. Change this as yeah, this one. Combination 255. Alright. 255. Oh, that's faster. I like it. I can turn off the light. Then yeah, do this, right? At least there's a clear numbering, and then I'll copy this, right? I'll copy this. This should be an imaginary one. This one, it is negative x and y, right? This is x and this is y. Is that correct? No, this is the y, so -1. But this one should be in imaginary, not exactly imaginary, but it's a broken line, so that we would say that yeah, this is not spawned yet. So line, broken line, really broken. Then can I say like it hurts me eyes. Okay, all right. So okay, so same explanation here. Yeah, uh, and then we create another one. We just copy paste this. We could just slide it, right? I don't want to do. I like it vertically than horizontally because it seems like it's easier to read, easier to browse. And then we copy paste this. Boom, and then boom. Yeah, I like it. And then the example here will be different. I'll move this. Oh no! I'll move this. Oh, come on. Can I, like, really? Okay. Put it there. Oh, come on. Oh, come on. Uh, put it here and then arrange it back. This one. Why I cannot? Why you know? Why you no move? Okay, I have to. I have to. All right. I'll just draw. The draw. This diagram wants me miss me drawing something. I'll give it to him. Jesus Christ, our Lord Savior. There you go. First try. Then brush. Perfect. Perfect voxel representation. So okay. Ah no. Ah no, the ghost. Ah. Oh no. The ghost. There you go. Leave us. Okay. I believe in Jesus. Here we go again. Here we go again. Save. save. Oh, it has a cache. Okay. Alright, so let's go back. So go back doing the same stupid idea. Okay. Alright. No, stop going. Let's draw the most perfect circle ever. Right. I didn't destroy anything, right? Right? Right. Okay. Now, this one. Why did I jump to play? Alright. This one, I have the example as this here. Alright. These are the vertices. So this is the grid 0, 0, 0, 0, 1, 1, 1, and 1, 0. Alright. So in a condition, something like this, so we have to change this as same. But in explanation, there will be something like this. So I don't know, but okay. Yeah, I'll just revise it along the way. And then this condition 0, 0. No, it's now the voxel is set as at coordinate 1, 1, x1, y1. Okay, and then let's proceed to create for the solution. So step 1. Text here. 1. Do the first one. Do this for each axis. X-axis first. So x. If grid is equal to 0, it's not. So we don't return. And then number 3, there should be a vertices for each y, negative y, and negative y. No, not negative y. Y minus 1 and z minus 1. So assuming it is really just positioned at 0, yeah, it's better to have this. Solution would be that. Then okay, we need to point out this. This is the V1. Start drawing. Stop, and then the text. What? Do not like that text. That's a bad idea. Style. That's a sketch. Not rounded. Yeah, we don't want sketch all the way. Merge the formal V1 to informal. We don't want to go full on freehand. Maybe it's good, but I really think for now it's not. So start drawing. Stop, then text. V1. Right. Perfect. So then solution 1 would be, so here we will iterate. As you can see, we will iterate it. So grid 0, 0, Nah, won't work. Iterate by x, yeah, now would work. And then this, yeah, so we iterate from uh, uh, first in, last out. First in, last out. So x, and then and then iterate to y, and then so 0x, and then full on y. So x, there should be, is there, uh, we do this operation, and then no, we cannot, because in step number 2 is 0. Return. Okay, then x1, no, x0, y1. Okay, do this, and then grid is no. If x is 0, grid is 0, yeah, no. So there should be vertices for each y and z. So that's true. 2 passes, and then three, and then vertices for y and z. There should be parentheses here. Won't draw for now. Yeah, to make it faster. For now, just yeah. Okay, so there's a y minus 1 here. So yeah, it has a, so it will test if there's a connection. So there should be a vertices for each y1 and y minus 1. But why have I been saying a y1? Y minus 1 and z minus 1. For now, this one I won't try. So okay, let's go back. So yeah, we we do this first step, yeah, in x-axis. We're just for doing for x-axis, and then in step 2 it passes to, because the grid x is not equal to 0. It's not. We are not here. We are here in x0. What? We're doing it in x0? Seems like my condition is wrong. I really think it is wrong. Oh man. If previous grid, I guess. No, no, no. No, 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 no. Now, this is true, but it should be applied to everything, everything. Uh, or grid y is equal to 0. Return. Yeah, not really. Not really. Not really. No, not really. Yeah, so if this is grid, yeah, it passed, and then number 3, there should be a vertices for each. Yeah, so this one. We've been trying to do this. Why we wouldn't be able to finish this? And then okay, yeah, y minus 1. Yeah, that's true. So we draw. We create a connection here, a mesh, a mesh. Connection from here to here. I believe we need right, right. Okay, we need that. The voxel should be really should be thicker, right? It should be thick. I cannot. All right. I'll delete it. Oh, okay. I could do this. I could do this. 5 points. Yeah, just two. Two will do. Just like in a couple. Two only will do. We don't need. We are not open, right? Just two. And then okay, we create that, which is the arrow from the yeah, we need the label. All right, we need the label. In every relationship there should be a label. Okay, how do we label this? All right, so let's go back here. So okay, I created this, then uh, if A B is past this test, so therefore we create mesh there from A to D. Okay, Z will always be constant because we won't be uh, demonstrating the Z here, but yeah, it always assumes that Z will always be constant at 0. Uh, or 1, so that it will always pass for now. Okay, so AD passed, and create a mesh, AD. So how would we? It should be facing here. Okay, the face should be facing here because when we are rendering, when we are passing vertices to the GPU, it needs the ordering ordering as well. No, we shouldn't delve into that deeply. So for now, what we want to know is if it is facing left or is it facing right. Okay, so this is weird. Ending facing right, and then facing. What? This is weird. If the voxel here is that's weird. This one left and not a start. That's weird. Left would be we are in a left right hand rule. So facing left, it should be facing right, correct? Because if the voxel is in here, but if the voxel is in here, which is +1, yeah, okay, that's correct. Because here the condition here, if it is a voxel, if it is here, the voxel is in here. If the voxel is here, but no, it didn't. It's not there. So therefore, the voxel is here, which is x+1, right? Face left, face right. So perhaps we could draw here. Move this, then move this. Just V1, and then here. Start brush. Perfect. And then make it stop. Make it stop. We're broken. Broken. Yeah, I think this looks better. And then change the color. Turn on the light. Then okay. 255, 255. Alright. Then turn off the light. Then start from. This is. Yeah, okay. VO. V0. So for determining the if yeah, the current grid. No, not exactly the corresponding grid. Yeah, because this is the grid and this is the voxel array. So this one, if uh, 0, no, face left, to face left, we no, uh, if that's coord, just coord, just call it coord, okay? If coord is yeah, this is very low level, I guess. We don't have to explain this, but I'll just put it. I'll just put it there. Um, yeah, this one should be the first one, right? that's the bad thing about this one. It doesn't take undo well. So if both true, yeah, and false, return. If not, generate uh, generate indices in respect with face condition. All right. Yeah, that's basically what we're doing, and then we are doing it in a to other to other axes as well. But uh, yeah, um, uh, for now, I'll try to implement this and then see if it works. There's so many edge cases, but for now, I think that's enough.